This is 12.1a of geometry. So we're going to start talking about circles. A tangent to a circle is a line that only touches or intersects the circle once. Okay? So if you look in this picture, AB, that red line there, is tangent to the circle. Okay, it's a tangent line. It's tangent to the circle. And that point B, where the circle and the line intersect, that's called the point of tangency, okay? If it only intersects once, there's only one point of tangency. So we have a theorem that if we have a line tangent to a circle, in this case it's at point P, then the radius that if you connect from the center to P, right, so this radius here, and our tangent line are perpendicular. Okay, so whenever you have a line of tangency, so whenever you have a tangent line, it's perpendicular to one of your radii. So, let's do our got it problem here. We are told that ED is tangent to circle O. So that means this is tangent to this radius right here. Okay, so this angle then is 90 degrees. So then I can solve for x because I know that angles inside of a triangle need to add up to 180. So 90 plus 38 plus x is equal to 180. 90 plus 38, that's 128, plus x equals 180. If I subtract 128, we get that x is equal to 52 degrees. If you look at the picture up here, notice you're working with a four-sided figure, right? This guy. Remember that there's 360 degrees inside a four-sided figure. Okay, so now we're going to look at the Earth and this airplane in our got it problem, okay? So let me sketch my Earth. Okay, you just picture it as a circle. So, the Earth's radius is about 4,000 miles. Whoa. So, this is about 4,000 miles. Okay, and then we have an airplane that's 2 miles above the Earth. So let me rough sketch in an airplane for us. And that's 2 miles. Okay, and then what it's talking about is there's a person on the airplane and they're looking to the horizon, okay? So remember, the horizon is where the sky and the earth meet, okay? When you're looking at the horizon, that's a tangent line. What your eyes are looking, I guess, is a tangent line. So it's only going to touch once. We'll say it touches about there. It's a rough picture here. And of course, going from the circle to our center is another radius, so this is 4,000 miles. And we want to know how far are we looking, how far to the horizon. And so if this is a tangent line right here, that means that this angle, although it doesn't quite look like it on the picture, is 90 degrees. So let me sketch this triangle separately. Okay, here's x, what we're looking for. This side is obviously 4,000 miles. The other side, though, is 4,000 miles plus the 2 miles. So 4,002 miles. If we have two sides of a triangle trying to find the third, we use Pythagorean Theorem. So a squared plus b squared is equal to c squared. Your legs, these two guys, are what go in for a and b, right? The legs are the thing that are connected to the right angle. So x squared plus 4,000 squared is equal to 4,002 squared. Squaring these, we're going to get some big numbers here. So we'll still have our x squared plus, if we do 4,000 squared, we get 16 million. And if we do 4,002 squared, we get 16,016,004. So I'm trying to get x alone. I'm going to subtract 16 million from both sides. So x squared is equal to 16,004. Then to get x alone, I'm going to square root it. we get that x is equal to about 126.5 miles. So the horizon from where this person on the airplane is looking is about 125 miles, depending on how we went around it. Okay, so we have the converse of that first theorem. If the radius and the line are perpendicular, then that means that the red line here, AB, is tangent. So, let's look at our got it problem here. So, there's a right angle here, which means that this is a tangent line. Okay, but what we want to know is we want to know what the radius is. So, you see that we've got two x's, right, because this is a radius and this is a radius. It's a right triangle, we can still use Pythagorean Theorem. So a squared plus b squared equals c squared. Let's quick sketch this to the side. This would be x, this is obviously 10. This side, the hypotenuse, is x plus 6. Okay, right? This is x, this is 6, so the whole thing is going to be adding them together. So, my 10 and my x are my legs, so x squared plus 10 squared. And I got to plug in x plus 6 with parentheses in for c. You cannot just distribute that squared in. You can't put it in, call it good. Doesn't work that way. I would suggest using the table method to figure out what we get. You can use FOIL, you can use the distributive property and setting it up. That's two ways that this series of textbooks teaches in the algebra textbook. I think the table method is the easiest way. So x and 6, x and 6. X times x is x squared. X times 6 is 6x. 6 times x is 6x. And 6 times 6 is 36. And then I add that up. X squared plus 6x plus 6x plus 36. And I can combine these two guys. X squared plus 12x plus 36. So I can plug that in right here if I've got room. And on the left side I get x squared plus 100. So you might be like, oh crap, there's x squareds. Don't worry, we can just subtract an x squared from both sides because they're on both sides, so they cancel out. So we get 100 is equal to 12x plus 36. Don't forget, our whole goal here is to solve for the radius. What is x? So I'm trying to get x alone. So I'm going to subtract 36 from both sides. So 12x is equal to 64. And if I divide by 12 on both sides, we get that x is equal to 5.3 repeating. So let's just round it to 5.3. And that is our radius. And there's your homework.